Okay, I think we'll start the session for today. The webinar on creating efficiency map analysis of axial flux motor using JMAG Designer. So, myself, Supriya, I am the technical sales engineer for the JMAG in India. So, currently handling the business for the JMAG. And my colleague, Ms. Kirtana, she is the application support engineer for the JMAG. So our agenda will be like be starting with a business presentation for the JMAG and followed by the technical presentation by Ms. Kirtana. So yeah, welcome all. So I'll start about our company's presentation. So we are Powersis. We started in the year 2002, and we are experts in model-based simulations software. And we are a Europe-based company, and we are experts in EV-based. And we have 30 plus electrical engineers across North America, Europe, and Asia. So mainly we do follow manage technological evolution, increase the drive robustness, mitigate your production phase risk, and decrease your time to market. So this is our team who are working together in order to fulfill all the customers' requirement. And our electrical engineers are being trained to work on whatever technical queries have been arised from customers. So these are our offices placed. You can see this is a global presence what we have, and we have 9 offices across the world with 50 plus employees and 30 plus EM engineers and Western class technologies. So we are placed in Germany, Paris, US, and India. So yeah, so India mainly focusing. We have 2 offices, one in Bangalore and one in Chennai. Bangalore office mainly focuses on servicing, giving services to the EM technologies, that is JMAC tool, and Chennai office mainly focuses on the power electronic tools, that is our own developed tool, Simba. Yeah, so we are on a mission to move motor design to one prototype. Our solutions enable OEM to minimize hardware prototyping, decrease development time, increase precision for e-motor design. In turns, it decreases time to market and increase profitability. So yeah, so these are our main focus market. You can tell since 2002 we have enabled clients in e-mobility, infrastructure, automotive, EV, home appliances, digital equipment, electric power facilities, factory automation, academics, and everywhere. So worldwide, to manufacture more robust, optimized electrical components and systems, we are giving services throughout. So we have a strategic partner with JSOIL. JSOIL are mainly focusing on developing, and we are focusing on the business parts. And yes, we are experts in electrifications and expert in EM technologies. So our main strategic focus, strategic products are electromagnetics and power electronics. Electromagnetics mainly with JMAG and power electronics with Simba. So you can tell in EV market in India, we have a paradigm shift. Until 2021 to 22, it has been taking 16 months to design a car, and it has been taking 30 plus hardware prototypes before production. None of the companies have been profitable. After the use of an EM simulation tool, that is JMAG, it's been taking 24 months to design a car and one hardware prototype for e-motor production. So yeah, you can tell this is a shift after using simulation software and the HPC platform. So definitely we are on a high accuracy. We are a high accuracy platform, large scale computation, and mainly with a 2D low computational and 3D high accuracy. So JMAG is the only technology to enable high accuracy, massive computation for e-design on cloud and on premise. Big number of high risk accuracy data is a key for AI and machine learning. So yes, compared to other competitors, we have an FEN tool which where you can do the mesh calculation and the HPC calculations. So yeah, coming to the deep dive into the independent benchmarks that has been done is 27 times faster than main tool on market. You can see the 3 types of analysis which we have done for one of the tier 1 large OEM and startups. So it's been taken for 2D optimization 11 hours from JMAG and 36 hours from Maxwell, which is 3x faster. And for 3D large model, it's been taken 2.5 hours from the JMAG and 22 hours for the Maxwell, which is 9x faster. So in terms of 3D model with 6K elements, it's been taking 0.6 hours with JMAG and 16 hours with Maxwell, which is 27x faster. So yeah, these are some of the clients which has been given from Ford, Lucid, Careford, and Daniker. So design time, accuracy, and cost are today's priorities for all major car manufacturers. So in terms of value proposition, definitely we are an electrical design optimized for performance and manufacturers, and definitely for the reduction of your project and development, we are 20 times faster with the simulation and calculation from the HPC platform as well. So these are our two main products for the JMAG, which is an e-motor design software, a simulation software for design of all your electrical devices, and the power electronic tool Simba, which is our own developed tool, which is our next generation tool for electromagnetics and power electronics. Yes, we are committed to ensuring our clients and innovations which eliminates the risk and increase the speed and accuracy, where accelerate your timeline for optimized prototype which is ready for full rate production. So coming to our client section, so these are our clients worldwide, which we have been serving from last 20 years with 2,500 happy customers across the world. So these are also some of the clients. Aditya Havels, coming to the automotive section with BHEL, PICL, Mercedes-Benz, which is our customer, and Bosch, which is going to be a global customer in some days, and Velia is already our global customers. So we have been serving these customers, not only restricted to this, also academics, you name any academics, we have been serving them now. And these are some of the academic sections which are our valuable clients. Yeah. Thank you from my end. If you need any further details, definitely you can note down the contact details. You can contact me. Thank you. I'll hand over to Ms. Kirtana for the technical presentation.
Yeah, thank you, Supriya. Thank you for the business presentation from your side. So let me share my screen. Kindly, please acknowledge whether you can see my screen, okay?
Yes, I can see your screen,
Yeah.
Kirtana.
Yeah.
You can proceed.
Yeah, thank you. Yeah, good afternoon all. And so on behalf of our Powersis team, we welcome all the participants for this webinar on creating efficiency map analysis of axial flux motor using JMAG Designer webinar. So myself, I am Keetana, so working as an application support engineer in Powersis. So to start up with the presentation, so I'm going to give you a basic overview of our finite element software, which is JMAG Designer, and directly get into the design and development of axial flux motors. And after that, how to design it through our finite element software, and what are all the settings to create the efficiency map analysis study. And finally, we'll end up with the results. So these are the contents for this webinar. And yeah, so to dive into the background of axial flux motors, so you people already know that axial flux motors are gaining more interest towards research nowadays. So because of its size is very 50% reduced compared to radial flux motors, and it also has a very thinner construction, and also because of its efficiency is more, and it is used for wide speed applications. So most of the electric vehicles and in vehicles uses axial flux motors. So the future for axial flux motors is bright. So where in which computational power like high power computation and AI integration and user friendly third party softwares can also be integrated, and the simulation can be done as a part of motor and drive. So efficiency maps, where efficiency maps play a better role is, so if axial flux motors has proven more than 95% of efficiency, and to prove how efficiency it will be in the wide speed regions, so for that finite element softwares like JMAG Designer will play a role. So this webinar explains detailed procedures and explanations regarding how to create an axial flex motor in JMAG Designer, and what are all the settings we have to do to create the efficiency map analysis as an application study. Okay, so yeah, so just let me introduce a basic overview of JMAG Designer, like JMAG structure, strengths, and motor design workflow. So JMAG structure is like, so first of all, how the data connection can be done with the software and the physics. It involves solvers, pre-post solvers like electromagnetics, electrostatics, thermal, structural, which is multiphysics, and thermal stress analysis can be done in the pre-post solvers. So this is how the software and the physics, electromagnetics part is connected with the solvers. So the next is efficient HPC implementation and optimization, so which is high performance computation. We have massive parallel processing units, and we have SMP, in which more than we have ANS cluster in which JMAG Designer can be is already there, and we can use more number of cores in order to reduce the simulation time. So in which high performance computation plays a major role. And optimization also, we have parametric and topology optimization, multi-objective optimization platforms, in which large number of data can be processed and the optimal design can be obtained from the JMAG Designer, which is a finite element analysis software. Yeah, and also we have common CAD interface for the JMAG Designer, in which like softwares like SolidWorks, CATIA, Creo, and NX, all these CAD files can be imported into JMAG Designer. Also, we can directly import a CAD file which is of all these formats, which is mentioned here, which is like SAT, DXF, Parasolid, IGS, STEP, all these DXF formats can be directly imported into the JMAG Designer. Okay, so then after that, after the model is imported, so we have all these operations like parametric optimization, including all the different types of optimization, Pareto curves, and yeah, we also have a scripting option, which is JavaScript and VB script. So integration of different simulation tools involve third-party software integration. So once the electromagnetic simulation is done, so it can be integrated with the third-party softwares like MATLAB, PSIM, LabVIEW, AMSESIM, OpenRT. So all these kinds of partner products can be integrated with JMAG Designer. Okay, so yeah, JMAG strength in electromechanical design cycle. So yeah, so this is the design cycle in which first we will be involved in the conceptual design. So initially we'll be having a set of inputs, so which can be processed through our JMAG Express tool, which is a pre-designed analytical tool in which you just enter the values and you get the output results. So, and also the model from JMAG Express can be directly imported into JMAG Designer, so which is a finite element analysis tool, in which all the mesh analysis and multiphysics like thermal and structural analysis can be done in the JMAG Designer. So all the EM forces calculations and loss analysis like copper loss, iron loss, magnet loss, hysteresis, eddy current, so all those losses can be viewed in JMAG Designer. And as I mentioned, for optimization, we have topology optimization, parametric optimization, multi-objective genetic algorithm optimization. So with the help of Pareto curve, so the best suitable objective function can be defined, and it can be directly, it will impact in the model, and optimized result will be obtained in the optimized design. Yeah, so after that comes the characteristics map, which is application study. So in order to prove the efficiency of a model, so for sure we have to go for efficiency map analysis, in which we can view the efficiency for different speed and torque ranges. So this is all about efficiency map. And not only efficiency, all the other losses like mechanical losses, LQ values, IDIQ values, and all kinds of losses can also be seen in this application study called efficiency map analysis. Yeah, so after that we have another software called JMAG RT, in which all after all this process, it can be converted into a 1D model, and it can be connected to third party softwares like MATLAB Simulink, which I mentioned in the previous slides. Yeah, so apart from this, we also have multiphysics coupling. So we can also analyze the thermal behavior and the structural behavior of any kind of motor. So the heat transfer from one part to another of the motor can be analyzed, and also the vibration and noise analysis can be done in this multiphysics coupling concept. So yeah, this is all about JMAG's strength. And yeah, so next is the design workflow. So how JMAG's workflow works as a V cycle. So the purpose of this V cycle is to reduce the number of prototypes and reduce the time to market. So as I mentioned, so the concept technology selection, we have software called JMAG Express Classic and JMAG Express. So these both are the analytical tools. So once you give the input, you will directly get the output in just 1 minute, in just one click of the simulation. So also we have all the predefined templates for stator, rotor, everything. So we can just select it and the motor will be built. So after entering all the details, so directly we can, in a single click, we will get the basic like torque speed characteristics, current, all the outputs can be viewed as an output. So after that, so optimization with global parameter set, which includes Pareto curve, and the best optimized result will be chosen as a output for the motor design. Yeah, so once it is done, so as I mentioned, from JMAG Express also, it is able to directly import the model into JMAG Designer. Once the model is built in JMAG Express, directly we can import the model into Designer for finite element analysis. So here the meshing and all the other things can be done. So all these left hand things can are system in loop simulations, in which express models can be taken back to designer. And even if you want to edit a model in designer, you can edit it in the CAD interface and you can take it back to the designer model. So these are all system in loop simulations. So model in loops simulations include, so after once the electromagnetic simulation is done in the JMAG designer part, so the model can be taken directly into the JMAG RT and it can be converted as a 1D model. And finally, so it can be taken to directly to the hardware in loop simulations. So this software can also be directly connected with the drive part for system verification and calibration. So which finally leads to the product verification and testing. So which finally reduces the time to your market. So this is where finite elements analysis softwares like JMAG helps you to reduce the time to market. So yeah, with that, let's get into the design and development of axial flux motor. So yeah, as I mentioned, so axial flux motors are nowadays mostly adopted for wide speed range operations. So yeah, in which motor's performance can be evaluated with the help of efficiency map analysis, and it can be also calculated by manual calculations through like if you have the torque values or voltage, torque equations, current. So it can be manually calculated. But the major issue why we have to go for finite element tools like JMAG Designer is, so the loss analysis and its nonlinear magnetization characteristics cannot be accurately calculated by means of hand calculation or manual calculation. So this is where efficiency map analysis plays a major role, in which you can efficiently calculate the motor design. So accurately calculating the efficiency is a similarly challenging part. So here, this is where the finite element tool comes in. So yeah, these are the precondition assumptions for the targeted axial flux motor which we have chosen. So the motor consists of a stator and a rotor. So the stator consists of stator core and coils. So and the rotor consists of a frame and magnets embedded in it. So the rotor is the rotate will be in the rotating motion. Okay, and obviously efficiency is calculated when the rotor is rotated at constant speed, and the input here is three-phase AC power. So yeah, so let us get into the constituent parts one by one. So the motor specifications. So this is the geometry which is chosen. So it is a 16 pole 18 slot motor, and it has a stator core Audi of 218, and ID is 110, and it has a thickness of 7.5 mm. And yeah, frame geometry, it is outer diameter is 218, inner diameter is 70, and the thickness is 13, and gap length is 1.7 mm. So this is the whole view of the AFM. So the materials. So next is the materials. What are the materials we are going to assign for each part? So the stator yoke is made up of Sumitomo Electric Industries HB3 reversible 20-degree, and frame is made up of JS or SUS stainless steel material, and magnet is ferrite magnet, and the coil is obviously made up of copper. So yeah, so these are the materials. And winding specifications. So as I mentioned, the input is a three-phase AC, and here the number of turns is 21 turns per phase per pole, so which is on the upper and the lower side both, and the resistance is 0.1 ohm per phase, and slot connection is in series, so it is a concentrated winding, and it is star connected. Okay, so yeah, these are the drive conditions. So it is a three-phase sine wave drive, and so the control type is maximum output control and maximum efficiency control. So the maximum RPM of this motor is 500 rotations per minute, and it is a 200 volt and 75 amps input inverter rating. Yeah. So yeah, in this model, we have two kinds of design proposals. So design proposal A includes a flatness ratio of 0.24, and so B is 0.42. So just it is a small comparison of how, if the flatness ratio varies, how it impacts the torque and the efficiency of the motor. It is a small comparison. So yeah, let us get into the detailed design, how to build a axial flux motor in the JMAG Designer, and verify the results through finite element analysis. Yeah. So the points for modeling the axial flux model is, so axial flux, obviously it is a 3D model in which the flux will flow in all the three X, Y, and Z directions. So it is a 3D magnetic circuit, and it is modeled as a 3D geometry. And for the simulation time to reduce, we have taken it as a partial model. Even we can consider it as a full model also. So here, and also the rotor is the rotating region here. So these are the points. Okay. So once all the input we know, we directly get into the JMAG Designer. So this is the CAD editor window of JMAG Designer, in which we can edit the sketch here. Like we can create a new part, and we can edit the sketch, and we can extrude the part since it is a 3D model for each part separately. So for stator, magnet, frame, and coil, everything is modeled separately, and the reference planes and everything is assigned in the geometry editor. So we have all the options similar to a CAD tool in the JMAG Designer itself. So yeah, once the geometry editor thing is done, here we have an option to import the model into the JMAG Designer from the CAD to the designer window. So once the solid model is built and it is imported into designer, so you will see all the kind of parts separately as an assembly. So this is the stator, and this is the magnet and the frame part, and this is the U coil build, and this is the V coil, and this is the W coil. So these are the assembly parts which is taken into the solid model in designer. So after this, once the solid model is created, we can just create a new study for magnetic transient analysis. As I mentioned, all the physics can be modeled in designer. So now we are going for efficiency map analysis. So directly we can go for an application study, which is efficiency map analysis. And after clicking that, directly the study will be created in the project manager bar. Okay, so yeah, next the settings to create the efficiency map analysis. So yeah, so one by one, let us do all the inputs what we have. So first is assigning the materials to each part. So as we know all the materials, so we can just drag and drop it here from the material section, which is available in the toolbox. So we have around 730 materials which are given here inbuilt in JMAG Designer. So whichever material you can search, you can just drag and drop it in the corresponding parts which you want. So magnet is a ferrite magnet, and coil is copper, and frame is a stainless steel material. So all parts are dragged and dropped here. So once you click on the materials part, so it will highlight whether it is correct, aligned, like assigned to the correct part of the geometry. So that can be ensured with the help of the materials part also. Okay, so after once the parts and the material section is done, next is the condition settings. So for the motion settings, so the rotor is set to be the rotating motion. So we have to right click on the rotation, motion rotation, and we'll be entering the speed value here. Since it is an arbitrary value here, JMAG Designer, it will take it as an automatically assign the value here. We can enter it as speed. And so after this, we'll go for coil modeling. So here we can just set the current flow region and current flow direction for each of the phases. So for U phase, we can directly like click on the fem coil, and we can assign the directions for each coil. And yeah, and the coil modeling can be done for all the three phases individually. So next is circuit modeling. So once all the conditions are assigned, so just we can create the circuit like with the current source and the star connected, since it is a three-phase star connected AC circuit. So we can just give all the inputs whichever it is available, and yeah, and the circuit modeling can be done. And also you have options to enter for the current source. So we can enter the amplitude, current amplitude here, and period mechanical angle, which is in time, and U phase electrical angle, which is in degree. Yeah, so all these values can be entered here. And yeah, so once the condition settings are also done, so next is the mesh. So to create the mesh, once we right click, we have the mesh properties. We have slide mesh, translational mesh, and according to the model, it will vary. So since it is a motor, it is always a slide mesh, which is in the rotor motion. So that is to be selected. And so method is semi-auto mesh. And so the model length and radial direction and in axis direction, it is according to our own interest. And so set the element size based on the gap length g. So it is so the number of elements which of mesh which can be defined. So we have already predefined values for this. So for all the parts, it is gap length into 2, and for origin alone, it is for gap length into 4 times greater. Yeah. And for slide divisions, so obviously it is mandatory to give the slide divisions, number of slide divisions for the extended side plane mesh. So the number of circumferential divisions here is 16 into 9. Yeah, so all these mesh settings are mandatory to create the mesh region. So yeah, this is how the mesh region will be looking. So which is including the air region. So it is air region alone, it is G into 4 times gap length. And so this is without air region. So all we have finite mesh element. And so the number of elements here is like around 1,63,000 elements, and 41,429 nodes are there in this mesh model. So yeah, so the time discretization, which is the step properties. So here we have to define, so for how much cycle the motor should run. So the divisions, so the divisions here are the recommended value for each divisions is from 4 to 32 in this model. So divisions is also it is an arbitrary value, and it is already built in JMAG Designer. So the number of steps will always be divisions plus 1. And so the step interval definition is a regular interval, and unit is in seconds. So the end time is obviously 1 by f. And yeah, once the setting is all the settings are done, so if we want iron loss also to be calculated for the stator core, even that can be added from the conditions. And here we have calculated only for the stator core. So we have set the iron loss for the stator core, and we have applied preset 1, so it is a FFT. And yeah, basic frequency, it will be calculated from the number of poles and the speed value. Okay, so yeah, iron loss calculation setting is done. And yeah, so for efficiency map also, we have actually 3 different types of efficiency map analysis possible in JMAG Designer. So first one is reduced order, second is speed priority, and third is accuracy priority. So reduced order method is based on very few preset data points, and mostly we will be using speed priority, which is like fast and also accurate. So which will include like some losses, iron losses, resistive losses, PWM and mechanical losses, some of the losses like joule losses, which can be included in the speed priority model. So accuracy priority model is about detailed loss analysis at all the operating points. It can include all the losses like PWM, AC loss, magnetic eddy current loss, etc. Okay, so once the type of efficiency, which type we have to choose, which is speed priority, and then we have to enter the response value table, and then so after executing the like we have to run the study, and the efficiency map results will be displayed in the map plot properties finally. Okay, so this is the steps we are going to see now. So these are the settings for efficiency map. So we have to create a response table. So with the method of speed priority, and obviously the torque here we have assigned as a rotor, and so n number of poles and three phase. So yeah, so the parameters we have to enter here is current and the phase angle in degree and speed values. So we are calculating it for one cycle. So once we click OK, and after running the study, so we will be having this project manager efficiency maps in the JMAG Designer result value. So in which we have to enter the maximum voltage and the maximum current. So once all these values are done, so we are going to calculate for the electromagnetic torque, maximum power and efficiency. So for both motor and generation mode, we are going to do, and so motor rotation plus torque, obviously. Yeah. So these are the settings which we have to follow for the efficiency map. And yeah, so once it is done, so these are the results for we have observed for both the designs. So as I mentioned, we had two flatness ratios, right? So for 0.24 and 0.42. So for the design proposal A, we have noticed that the torque is more, but the it operates in low speed regions. So design proposal A is for low speed regions. So but in design proposal B, it reaches higher speeds, higher efficiency in higher speeds. So here efficiency is more in the low speed regions, and here efficiency is more in the high speed regions for design proposal B, so which is flatness ratio 0.42. So this is a small comparison which we have done for the both the designs. And yeah, also we can, as I mentioned, we can also view id ld values. So this is one of the id maps. So here we can see increased d-axis current, and here the d-axis leakage flux is less for the design proposal B, so which is 0.42. And yeah, here also we can see that there is an increase in copper loss because we have increase in maximum torque, right? So and here we have less copper losses due to the less requirement of d-axis current. So yeah, so and so advantages of JMAG is so we have an inbuilt JMAG Express, which is an inbuilt template, and which takes less time, which is lesser than 1 minute to perform the basic performance characteristics. And we have JMAG Designer, which is a finite element analysis tool, which is developed for extremely high quality mesh for machine analysis. And as I mentioned, we have material database, which contains about 730 types of material properties, along with BH curve and loss curves, which is directly provided by the material manufacturers. And yeah, we have a very easy coil setting panel, which are easy to apply through an automatic coil winding tool, or by manually also we can directly import our own circuit into the circuit modeling panel. And also we can also evaluate the actual drive effects by connecting the machine model to a circuit model, and perform analysis by linking power electronic simulators like PSIM, MATLAB, Simba, and other third-party softwares. Yeah, so these are some of our customers as our marketing team introduced. So yeah, please feel free to contact us regarding any queries.
Yeah, thanks, Kirtana. We can also take some questions from the audience. Please feel free to drop your questions in the question and answer tab, and we can answer you. Kirtana, there are some questions in the Q&A tab. Please, you can answer those.
Yeah, I'm replying.
You can talk either. You don't need to spend time on typing.
Yeah,
You
okay.
can, yeah. Hmm.
After the setting, how to start the efficiency? Okay, I think for this Nirtara is replying. And so So yeah, let me get back with. We have some questions. So how to make distributed winding in the axial flux machine? So it is like we have to create it in the editor as a CAD design, and we can directly import it as a solid model. So I think some answers are answered, like yeah. So remaining questions. What is flatness ratio? So here I have mentioned. So the flatness ratio is defined by the axial length by the diameter. Here we have only varied the uh, flatness ratio, and all the other parts remains the same. So can we do efficiency map analysis in JMAG for the SRM machines? Yes. And how does the software evaluate PM losses? What is PM? So can we link SolidWorks directly to JMAG to create parametric geometry? Yes, you can take the DXF file from SolidWorks, which is model, and you can just directly import it into the JMAG Designer. So how long does it take to solve for 3D efficiency map? So it is according to whether it is a partial model or a full model, and according to whether you are using how many number of cores. So if it is a 8 core system and it is a partial model, so maybe within like 2 hours you can complete your results, can get your results. And so any idea about simulation time, how many cores are required? Yeah, like minimum of 6 to 8 core system is required for more faster simulation. Please give a short demo. Okay, for this, kindly contact us through our email. So I have mentioned our email ID, right? So yeah, if you have any other questions regarding the software, so kindly contact us through our email ID just mentioned here. This efficiency mapping is same for radial PM machine. Yeah, it is same. So how do you generate LDLQ maps? So once the efficiency map is created, in there you can view all the results for LDLQ and IDIQ, all the values you can see there only. We have options for that. And what was the rotor structure of axial flux motor used in your presentation? A rotor structure. It is frame and magnets embedded in it, right? Yeah. Okay, we have lot more questions. So I request you people to reply through uh, the below mentioned email IDs. And yeah, thank you for joining this webinar. And I think, yeah, it is good to close the webinar, and kindly share all your queries um, to the below mentioned email ID. So we all are FEA support engineers, and please also mention your requirement on the whatever queries or